Hi, everybody, and welcome to today's webinar featuring DBOS CEO Jeremy Edberg. He'll be talking about his experiences with and predictions for serverless computing. The AWS Lambda serverless computing platform just turned 10 years old, and Jeremy, through his engineering and DevOps experience at Reddit, Netflix, eBay, PayPal, and a bunch of others, has been on the serverless journey since the beginning. And now, as CEO at DBOS, he's got a lot of sway over the future of the technology, and he'll be sharing all that today. Okay, so without further ado, let me turn it over to Jeremy. Jeremy?
Thanks, Andy. So, as Andy mentioned, the year was 2014. It was reInvent, and AWS was introducing a new thing called AWS Lambda, using a new thing that they called event-driven computing. Actually, the chief product officer of Netflix got out to introduce use cases, and I got to write that part of the keynote, which was pretty exciting because I was working at Netflix at the time and had access to Lambda before pretty much anyone else. Before Netflix, I worked at eBay, PayPal, Amazon, so Reddit. I've been all over the place, and I've been doing DevOps for a long time. And serverless was exciting to me because it looked like a new paradigm, a new way to do things. So today we're going to talk about the promises of serverless, the realities of it, the problems with it, and some solutions. So a brief journey through history. In the 80s, we had the mainframe cycle. It would cost millions to hundreds of millions of dollars to do something. It would take years to execute. And basically, you were betting the entire company because if it didn't work, then you didn't have time to fix it. In the 90s, we got our costs down by an order of magnitude. We got our time down by a order of magnitude, basically. So you could bet less. You only had to bet, say, a division of the company at the cost of failure. And then in the 2000s, we came up with Agile or Waterfall, and we shortened the time again. We shortened the cost again. A failure would basically mean a product feature. It wasn't nearly as bad, maybe the reputation of the product manager. But, it was Waterfall, so you had to take steps. You had to go through product manager, developer, and so on and so forth. And then in the 2010s, we had this microservices idea. And then Lambda came in the middle of the 2010s and really accelerated this idea of let's do everything in small little services. It just costs a few dollars to tens of dollars. The cost of failure was barely negligible. You were betting tiny bits of code, and it made development easier, right? Because when we had when we had a single tree, everybody had to sort of get everything in there. And then we moved to this method of microservices where everybody would build and sort of merge at the end. Sorry, not microservices. Waterfall, where everybody would build and merge at the end. And then we went on to microservices, where everybody could build in their own little silo, and the application was a conglomeration of services, so little bits could be changed, and it was super easy for the developer. At least that was the promise, right? Small units of compute, super scalable, rapid iteration, easy to collaborate, all of those things. That was the promise of serverless. Serverless computing was all about speeding up development by allowing rapid iteration and getting rid of a lot of the overhead. So we moved from servers, where we had to deal with all of these problems, to serverless, where we didn't have to deal with any of them. But we did have to deal with different problems, right? And so the idea of Lambda was that it lets you manage your code and your infrastructure in the same place. You just upload your code and it runs. That was the magical promise, right? Or more importantly, it was letting the developers manage their code and infrastructure. And conception to prod in just 5 minutes. And it's not your infrastructure, so you didn't have to worry about it. So these were the promised benefits, right? No servers, no idle time, continuous scaling. So did Lambda live up to those promises? I don't think it did, and I don't think the internet felt so either. There was a lot of, uh, you know, a lot of interest in serverless at the time when it started. That first line over there, that's when it was announced, and then just a couple years later, the interest kind of leveled off. Never really kept growing or getting more popular. And when I say serverless, to be clear, what I'm talking about is auto scaling. It's the idea of upload your code, and the provider takes care of everything for you beyond that, right? Everything is automatic scaling. Everything, the data, the network, everything that you need just scales up automatically. But the reality is that in a serverless world today, the DevOps engineer still needs to be an expert on building reliably, right? You still have all of the problems with microservices, and you get to multiply them with serverless because now you have to worry about all the scaling and infrastructure with each individual service. This is the AWS recommended layout for a simple web request. You can see how many AWS services it involves, lots of data moving around, lots of management overhead, having to manage all of those different services, all that different infrastructure, all in different places. And there's three types of functions that work well for serverless today, right? There's the embarrassingly parallel, the function that doesn't really need any data or need to interact with anyone else. And so those can just be run independently. A lot of people use serverless today for the glue between services because it's actually really good for that. But what does that mean? It means moving data from one service to another or spinning up or down other services. So a lot of Lambda usage today is actually managing other services. Or it's a small part of a workflow that manipulates data. So some data comes in, it gets manipulated, it goes out. So let's talk about the problems with serverless today. Number one is it's hard to secure, right? With that many services involved, there's a lot of attack services. The logs all have to be shipped to a central place and reconstructed on a single request. So that makes security somewhat of a nightmare. And this, in fact, is a big hindrance to adoption in larger enterprises. Some enterprises have figured this out, but a lot will just avoid it because they don't even want to think about how to secure it. Bundling up dependencies. So you have to upload your code, but there's size limits, and you have to get all your dependencies in there. There's some workarounds that are kludgy, but where you upload part of it and then use a layer or something like that. And then they're time limited as well, right? So all of the major platforms limit execution time to 15 minutes or less typically. And you can see that AI image there. I asked it to make a stopwatch with 15 minutes, and that's the best it could do. And you often need an external service for scheduling your workflows. The serverless functions are designed to be ephemeral and quick, and so if you need to make sure that one happens after another, then you have to use an external service, and that usually costs extra and adds a lot of cognitive overhead to manage all of those repeating tasks and keeping track of all of that stuff. And it's hard to adopt open source software. Open source software typically is not designed for a serverless environment, right? It's designed to be built in a monolith. And if you want to use it in serverless, you have to tear it apart or you have to run it in a container. And that's another AI image. And don't ask me why there's those weird mechanical spiders, because I have no idea. And there's significant vendor lock-in when you use serverless today. Anything slightly complicated is going to lock you in because you're going to be using external services. You're going to be most likely adopting a bunch of other services within that provider, and it's nearly impossible to move your workflow out. And they're stateless, right? They're designed to be stateless, which means that they run and shut down quickly. The storage has to be somewhere else. The state has to be somewhere else. They have to communicate by passing data around. And moving data is the single biggest cost of any distributed system. So if you look at any distributed system, the cost of moving data around is going to overwhelm any other cost you have in that system. Shared state has to be put in a shared service. So that's going to add cost and overhead because that shared state has to be constantly updated in that service. And or you have to ship data around to keep that state. So you have to send the entire state of the system between functions as you're running. And both of these really break distributed computing models, right? In distributed computing models, the ideal case is the opposite. It's that you bring your compute to the data, right? You don't want to bring your data to the compute. And serverless today is not durable. Functions can fail silently, they can run twice, and you again have to use an external coordinator like something like step functions. But step functions has its own problems. It's got its proprietary configuration. It's slow. It charges you for every step. And in a lot of cases, people who are using step functions, that ends up being the biggest part of their compute cost because of all of the coordination and back and forth that's required. And testing is really hard. You can't really test locally. You can't test the network. You can't really shut down the network. You can't send JSON to the functions and compare the results because you're running in production. So testing is a very much unsolved problem in the serverless world today. And the cost, right? You're waiting, you pay for every microsecond that you're waiting for something to happen. And in a lot of applications, a lot of it is wait time. Sometimes up to 90% can be wait time. And this is extra bad in the world of LLMs. With LLMs, you could be waiting multiple seconds for a response for that LLM. And that's going to cost you. You're going to have to pay for that waiting time. And monitoring is really difficult with current day serverless. You got to follow that request all the way through, which means you have to have request tracing, which involves either attaching more data to every request or using a third party or external service. And it's really hard to have a comprehensive security posture when you have all of these extra services, third parties, data moving between different functions, and just the lack of observability, right? It's there's so many services involved. It gets hard to do that distributed tracing. You to reconstruct a past request can be a nightmare, especially if you're under an audit. And so that just makes serverless monitoring observability very difficult today. And you still have to think about the infrastructure. After all of that, all the providers still make you pick a memory size and a CPU size. And a lot of times you can't even pick them independently. You have to just choose if you want more memory, you need a bigger CPU that you have to pay for. Or if you want a bigger CPU, you got to pay for more memory. You don't really get much choice about it. And of course, there's the cold start issue, which most anyone who's used serverless is familiar with. It's the having to wait for that little VM to spin up the first time you make a request. And again, testing, right? We can't simulate outages. We don't really know what's happening. We assume that they're doing the testing, but we can't know for sure. And so some people might say, what about containers, right? That solves a lot of these problems. And that's true, but it adds new problems, right? It doesn't really scale to zero. You still have to have one container running. There's a bunch of management overhead. Anybody who's used Kubernetes knows how you're really just trading off one management overhead for a different management overhead. Oftentimes there's manual scaling involved because it tends to be hard to scale containers properly. And the deployment time is still going to be slow. It's, you have to build that container, you have to distribute that container, and there's certainly workarounds for this, but it's still going to be slower than just uploading code. So that is all of the problems with serverless. Let's talk about solutions now, right? It's no fun to just list a bunch of problems and then say you're on your own. I should at least provide you with some solutions. And the first solution I'm going to provide you with is the idea of the micro monolith. So you can actually run serverless AWS Lambdas as a micro monolith, right? You can put all of your code into a single Lambda, and that's actually a recommended best practice. But because the Lambdas don't have state, and because they have to run that, open that VM for the request, you're going to get an even longer cold start by doing that. However, micromonolith is a good solution because it brings the data or the code all into one place. And so a lot of the interactions between pieces of code end up local. You don't have to go out to another service. You don't have to ship data around. And it keeps the state and the code more tightly integrated, right? And I would even suggest keeping the state and code tightly integrated by keeping it tightly integrated with the database. And this may seem backwards from every best practice that we've heard in the last decade, right? You want to separate the database and the compute is what we're constantly told. And I would say that that may be wrong. In the largest of largest systems, perhaps that is a good solution. But for most every system at most every scale, keeping the database close to the code is actually going to give you a lot of advantages. And I'll show you about that in a little bit. And then treating everything as a workflow. So if you treat everything as a workflow, then it'll make things a lot easier because you can resume them, or you don't need a third an external service to keep track, things like that. So I want to introduce you to DBOS Transact, which is an open source library. The link is there, and we'll send it to you later as well. And the open source library Transact is MIT open source, MIT licensed. It runs completely locally, and it just uses standard Postgres. There's nothing special about the Postgres. It takes advantage of most every feature of Postgres to do its magic. And so you do need to have a fully featured Postgres, but any Postgres compatible database will work with it. And that's all you need is the Transact library and Postgres. So how does Transact work? It keeps a provenance DB that's separate from your application. It stores every state change in your application as a separate entry in that database, including all the inputs and outputs. And it resumes workflows where they left off. So with properly annotated code, which I'll show you in a minute, you can have your workflows and you can resume them and keep track of them and things like that. So for example, right, this is a stripped down version of what that database looks like. Those are transaction IDs. And so it keeps track of every input and output, and when the count of, say, the widgets change, which transactions are involved, so that if there's a crash or a failure or something needs to be resumed, it can go back and it can say, these are the transactions that were part of this, how far, which transactions were already successful, where do I need to pick up this workflow? And so what that does is it lets you really lets you manage your code and infrastructure in the same place, because all you have to do is decorate your code, which hints to the infrastructure what it needs to do. It reduces a lot of that cognitive overhead. So here's that same AWS recommended diagram, but with DBOS Transact in place of many of those services. It answers the question of hard to secure because attack surfaces are reduced. Logging is much simpler, and with inputs and outputs being logged, it makes for exceptional auditability. You can even do intrusion detection right on the provenance database as you're looking at what inputs and outputs have happened, and you can look for anomalies with simple SQL queries. That provenance database is still completely observable to the user. You can run any query you want on it. Again, it's not a special database, and so that makes it really easy to do secure audits. Excuse me. It answers the hard to bundle dependencies problem. With a micro monolith, you just have to bundle everything once, and the dependencies can be versioned together with the code using your package manager of your language. We support Python and TypeScript. In both cases, you can define your dependencies and version them separately, or with your code in separate files. And so by putting everything into one micro monolith, it makes dependency bundling much easier. You don't have to worry about the time limitations because by breaking everything into workflows, every little piece of interaction is very short, but it can be nearly unlimited time between workflow steps. So if you could wait days for the user to respond, and you don't have to have a connection sitting open, but you also don't have to write any special code that keeps track of all of the workflows that are open or anything like that. It's all built right in to the library. You no longer need an external service for scheduling because with everything being a workflow, that's a side effect of the system that's built right in. The database just has all the workflows and you can resume them from wherever you left off. And so you don't need that external scheduler anymore, which means reducing those external network calls and the cost as well. Adopting open source is super easy. Most open source is already built for running as a monolith anyway. And so with the micro monolith, you can just take what they supply. And if you add Transact decorators, you can add durability. So here's an example of adding durability to Swarm. All we had to do was add a couple of decorators to the existing code, and we had durable Swarm. And you can avoid vendor lock-in by using an open source library that can be hosted on a single server. It'll all run on its own if you wanted to. You don't have to worry about lock-in and third-party services because you don't need to use them. You bring your own database, you're all set. And it's no longer stateless either, because since individual workflow steps are quick, and the state is in the database, you don't have to pass a bunch of data around. It's all there, it's all in the database, and you don't have to worry about where the state is, where it's being kept, or anything of that nature. And durability is the crux of the Transact library. It adds durability to serverless compute. Since every workflow state is stored as its individual step, resumption, you don't need those external coordinators. So durability built right in. And it makes it makes for good, much easier testing, right? You can do all these things. You can do local testing. You can run it fully locally. You can send JSON right into it and see what happens. You can test the network if you want, if you're running it fully locally. And then we do offer a cloud service as well. And you can see all of the other AWS services that were eliminated by launching our cloud service. And we run in AWS. So you can still use your favorite AWS services if you want to. But the cloud service takes care of some of the other problems. So we built our own cloud on bare metal in AWS with a very thin Firecracker VM. And that VM, in fact, is the same one that they use to build AWS Lambda. So this reduces costs significantly if you use our cloud because you don't have to pay for waiting for responses from LLMs or users or anything like that because those are separate workflow steps. So nothing is running during that time. Everything emits OpenTelemetry metrics. Tracing is built right in. So all of that is solved with our cloud as well. You don't have to worry about managing all of that. It's all built right in. And if you want to, you still can, right? If you have your favorite OpenTelemetry consumer, you can still send the metrics there and do whatever you want with it. As I said earlier, the provenance DB is completely queryable by the user. So you don't have to worry about that either. And you can build queries right against it for auditing, for example. And that goes right into the observability as well, right? So all of the inputs and outputs are saved. That makes auditing easy. No more distributed tracing, no more reconstructing things. We have a time travel debugger built right in. So you can replay old requests to see if you identified a bug or a potential attack. You can replay them to see exactly what happened by looking at their inputs and outputs. So all of that lends itself to a better observability, better auditing, easier to audit, better security. And you don't have to think about the infrastructure because we truly do scale it for you. And one of the nice side benefits of keeping everything as a resumable workflow is that if a workflow does fail because of a lack of resources, it can just be rerun on a bigger machine. So you don't have to worry about the CPU and the memory because you can just rerun your workflow on a bigger system if it runs out of resources. And there's fun things you can do like predicting how many resources a workflow might need and making sure to just run it on the right one in the first place and things like that. And of course, the cold starts get eliminated because the micro VMs are always running and ready for a request. because we just have a large fleet of micro VMs. And sometimes, in the future, we may even have the ability to predict which workflow steps are coming next and pre-run parts of it or have it running and waiting. And so with our cloud, you don't have any cold start issues because they're always running and waiting to execute the code. And with that, I will take a Q&A if anyone has any questions.
First one is about Swarm. Could you tell people what that is and when does it need to be durable?
Yes, so Swarm is an open source library that helps you run your AI agentic workloads. So it helps manage, when you want to take a thing and put it into an AI and then do another thing. And one of the things that was missing was durability. And then when we annotated it, we added durability to it. So now you don't have to worry about, did I get my response from that LLM or did I get my thing done? Because it'll rerun if it didn't.
Thanks. And another question here about cold starts. How long does a cold start normally take?
How long does it normally take? So if you're talking about something like AWS Lambda, if you're running in Python, a cold start could be maybe 1 second or a little bit less. If you're talking about something like Java, it could be 10 seconds plus. It really just depends how long it takes to start up that virtual machine. But it not only does it depend on the virtual machine, but it depends on what libraries you might be running. If there's an initiation, sometimes depending on your code, it could take quite a long time.
The Postgres database that DBOS Transact connects to, can that DBMS also be used to store your application data?
Oh, yes, I did not make that clear, but yes, you would store your application data with your in that same database, and then all of the updates to the data are wrapped in the same transactions as the updates to the provenance database, which is part of what gets us the durability because we can then guarantee that the workflow step is registered in the same transaction as the data update itself.
Okay, and I think last one here. This is a DBOS Transact. You mentioned DBOS Cloud runs on AWS, but DBOS Transact, that can run anywhere?
Yes, DBOS Transact is the open source library that you can run it anywhere you want. You can even run it in AWS Lambda if you actually want to, although I wouldn't recommend it. But yeah, you can run it anywhere you want. DBOS Cloud today runs in AWS, but in the future, DBOS Cloud will probably be available in Azure or Google, or it could even be run on-prem or in your own VPC, for example.
Okay, and actually one more. Can you talk a little bit about the language support for DBOS Transact? Somebody asked whether it supports, whether it's available for Java yet.
Yeah, so today we support TypeScript and Python. In the future, we will support more languages. The truth be told, Java is probably coming soon, but not right away. Java is a lot harder to do because of the way that Java operates and all of the dependencies and libraries that need loading. So Java's a little bit harder. Probably the next language would be Go or Rust or something of that nature, would be my guess, but we haven't really decided yet.
Thanks. Yeah, we just released a major upgrade to our TypeScript library last week. So
Yes, I should have mentioned that. Yeah. TypeScript library V2 just came out last week, and Python in September.
Yep, last September. Okay, cool. I think that does it. If anybody else has any questions, feel free to join our Discord channel. It's available from the website and ask away there. We're on there all the time. And want to thank Jeremy for sharing today. Great talk. And thanks everybody for attending and hope to see you online at a future event. Thanks again.